We are all here because we're mobilized to try to induce a rapid energy transition towards cleaner forms of energy production and use. But we're confronted with two key challenges. One of them is that energy transitions are inherently slow. They take a long time. And two, taking any kind of advanced material from the laboratory into the marketplace takes a long time. And so when we couple those two factors together, taking an advanced clean energy material into the marketplace will take a very long time unless we do things very, very differently moving forward. So our mission here is to develop ways to accelerate materials discovery by at least 10x as we move forward. This is the mission of MI6. In 2007, a workshop was held in Mexico City with thought leaders and stakeholders from around the world, and this workshop was hosted by the Mexico, US, and Canadian governments. And a key outcome from this meeting was that we needed to invest in a materials acceleration platform. That is, a system that leverages recent advances in artificial synthesis and automated tools for synthesizing molecules and materials, and for tools for automating the measurement and characterization of these materials. And being able to close this loop so that way we can actually build an autonomous robot to go through and do these experiments much more efficiently moving forward. My name is Curtis Berlinguet. I am a professor of chemistry at the University of British Columbia, and I am part of an academic group that is putting this strategy into action today. I am launching this project in partnership with my colleagues Alana Spiru-Guzik, who's moving to the University of Toronto this summer, and my colleague here, Jason Hein, also from the University of British Columbia. And we are leveraging the expertise of Alana, who is a world expert in applying machine learning and AI to finding the best clean energy materials as quickly as possible. My colleague Jason here is the pioneer in developing robotics to help automate chemical synthesis. And then my program has had a long-standing interest in developing rapid automated measurement tools as they relate to the development of clean energy technologies ranging from advanced solar cells to energy storage technologies to CO2 utilization technologies. We're really excited to get this project off the ground. This is not the stuff of science fiction. We already have robots that are in action today. This is an example of one of the robots that is in Jason's lab. It's an artificially intelligent robot that provides an autonomous laboratory platform that is effectively a self-driving laboratory. This robot designs the experiment, executes the experiment, processes the information from that experiment, and then decides what the next experiment will actually do. That robot is making all of these decisions much more efficiently than humans currently can do. So we're working to bring the speed of science up to the speed of thought. This particular robot already has quite an internet following. I provide here with a Twitch feed in the lower right-hand corner if you want to see this robot in action. And you can even provide some input on what you'd like to see the robot doing moving forward. And I encourage you to reach out to Jason if you'd like to be involved in that. So we know that automation and robotics works. We've seen this reduce the costs and increase the efficiencies in manufacturing. We've seen this in biology with the Human Genome Project. We haven't seen it yet in the materials space. And that's why we're leading this right now, is we're going to be the first to really do this. And so with that, we're really energized to get this project off the ground. And we certainly invite a much broader global effort to work with us to build a smart and fast, clean energy materials factory. I hope you will join us. Thank you.